All right, so carrier screen. There's a test that they recommend that the egg donor and the sperm donors take, and this is basically testing to see if anybody is a carrier for a recessive genetic disorder. So basically, company Inviti will be testing for 289 recessive genes that lead to pretty severe genetic disorders. So what does this exactly mean? Well, basically, each of us have 2 copies of our DNA. So 2 genes, copies of every single gene in our body. There's something like 20 to 30,000 different genes in the human genome. And they come in different versions. And for our discussions here, we'll be talking about the dominant version of a gene, capital G is what we'll use to represent it, and the recessive version of the gene, or a little g tree, to represent that. Now, there are dominant genetic disorders. There are many genes that are both dominant and recessive versions, where both versions are normal and fine, say for hair color, eye color, skin color, things like that. But in our cases, we are specifically talking about recessive genetic disorders, where the dominant versions, the capital G, are normal. And if you have at least 1 copy out of your 2, that's a capital G, a dominant version, then you are normal. You do not have that disorder. And the lowercase g, the recessive version, if someone has 2 copies of that, then they have the genetic disorder. So that would be defective. Again, so this only works for recessive genetic disorders. So the possibilities for the donors, the sperm donors and egg donors, are that they will either be possessing both dominant versions of the gene, so capital G for the 2 copies, or they will have a dominant version and a recessive version, capital G and a lowercase g. And that would make them a carrier, meaning they could potentially pass that lowercase g, the defective version of the recessive gene, on to their offspring. None of the donors are going to be having the genetic disorder, or at least none of the donors will be surprised to find out that they have the genetic disorder. Again, these are severe genetic disorders. If you have it, you will know you have it. So none of the donors are going to be lowercase g, lowercase g. So let's say both donors, the egg donor and the sperm donor, are carriers. In that case, one of their copies is the dominant version, the capital G, and one of their copies is the recessive version, the lowercase g. And when they make the sperm or the egg, it'll only get 1 copy. So it'll either get the dominant version or the recessive version. So either for the sperm or the egg, it'll have either the dominant version or the recessive version. So if you do the probabilities, matching across the chart, you'll find that there will be 25% of the resulting embryos will be capital G, have both dominant versions. 50% will have a capital G and a lowercase g, so they'll be carriers, but they will be normal overall. They will not have the genetic disorder. And only 25% will be lowercase g. Only 25% of the embryos would have the genetic disorder. So when both donors are carriers, 75% of the embryos will be normal, will not have the disorder, and 25% will have the disorder. That's 25% of your embryos, and there aren't going to be that many embryos to begin with. So that is not an ideal situation. Plus, it's not always possible to test for the embryos whether or not they have this disorder before implantation. So you'll end up having a possibility of 25% of the implanted embryos having the disorder. So the basic goal is to try to make sure that the donors are not carriers of the same disorder. So what you want is, say, for instance, the egg donor to be capital G, so is not a carrier for the disorder. And then the sperm donor could be a carrier, might not be a carrier. It doesn't matter because every single embryo, all 100% of the embryos, will get the dominant version, the normal version of the gene, and will not have the disorder. So the purpose of these tests is to make sure that the egg donor and the sperm donor are not both carriers for the same disorder. And as I mentioned before, the tests are testing for 289 different genetic disorders, recessive genetic disorders. And many of them, most of them, you will never have heard of before. But there might be a few. Tay-Sachs disease is relatively well known. I know I teach about it in my human anatomy courses. So basically, this is what the test results will include, is this information about the different genetic disorders. It tells you the name of the genetic disorder, the gene, the specific gene that has the dominant normal version and the recessive defective version. And since there are 20 to 30,000 different genes in the human genome, they end up having slightly more letters in their names, sometimes numbers. Then it also breaks down as to whether there are some ethnicities that may have a higher percentage chance of being carriers. So wherever it says pan-ethnic, that means pretty much everybody. So spondylothoracic dysostosis, pan-ethnic, so most everybody, you have a 1 in 224 chance of being a carrier. But if you are Puerto Rican descent, then you have a 1 in 55% chance of being a carrier. And then after this test, after you receive this test, if it says you are not a carrier, then technically that doesn't mean 100% that you're not a carrier. There's still a chance that you might be a carrier, but as you can see, it's dramatically lower. You might also see in some examples, say Stuve-Wiedemann syndrome here, pan-ethnic for everybody, they say less than 1 in 500 chance of being a carrier. And after the test, they put the word reduced. That means that it's close to 0, but they will never say that it's 0 because nothing in this world is perfect. And then going back to Tay-Sachs disease here, as you can see, there are a lot of different ethnicities where they have a higher frequency of being a carrier versus the pan-ethnic versus everyone else. And again, these are all severe recessive genetic disorders. So again, you would know if you have it long before you would be taking a test like this. But you wouldn't know if you're a carrier. So you would not know if you're a carrier. Now, if it turns out you have family history, you have a sibling who had the disorder, or a cousin or something like that, then that could mean that your chance of being a carrier is significantly increased. All right. I got my results, and one of the possible results was what they called a pseudodeficiency allele. All this means is that I had a normal gene that's a little different from most people's normal genes, and I don't have the disorder at all, but it shows up on the test. So they said, oh, look at that, I have a benign change, I have a perfectly normal gene for the GALC gene. It is normal. It does not cause the disorder. So I am not a carrier. I do not have Krabbe disease. So that's another possible result out there because there's a lot of genetic diversity in the human species. So many cases of normal genes that are a little different from other normal genes. All right, some disclaimers about all this. Well, again, the company does not guarantee 100% results. So they do say that it's a lot less likely you're a carrier if you tested negative based on them. And then, of course, this only covers 289 recessive disorders. And there are a lot of other possible disorders out there. There are probably other recessive disorders that they just don't have the genetic information for to test for. There are other genetic disorders that are much more complicated, that involve more than one gene, could involve many, many different genes. There are, of course, chromosomal disorders that would not be detected by a test like this, such as having an entire additional chromosome, such as in Down syndrome, trisomy 21. There are, of course, many disorders that have both genetic and environmental factors. So, for instance, I happen to have narcolepsy, which has both a genetics component and an environmental component. I looked up the statistics, and the odds of me ending up producing an offspring with narcolepsy is 1%, much, much higher than having someone randomly get narcolepsy, but relatively rare. And then, of course, there are disorders out there determined solely by the environment: fetal alcohol syndrome, clubfoot, cerebral palsy. So there are possible disorders that have nothing to do with genetics necessarily. So getting this sort of screening does not guarantee that the resulting infant produced will not have some sort of congenital disorder. It just dramatically decreases the possibility of the infant having the 289 recessive disorders that were tested for. And finally, just to remember, being a carrier is not a bad thing. Most people are carriers for something. You just want to try to decrease the likelihood that whatever disorder you're a carrier for is not the same as the egg donor. Be sure to subscribe and like.